In this video, we're going to talk about one-sided limit. Before we do that, let's review greatest integer function. If you recall from pre-calculus, greatest integer function, when you graph it, it looks like a step function. So what will be y equals greatest integer of 0.5? Meaning that what is a integer that is less than or equal to 0.5? What is the greatest integer that is less than or equal to 0.5? That will be 0. So greatest integer of 0.5 is 0. What about y equals greatest integer of 1.3? What is the greatest integer that is less than or equal to 1.3? That's 1. What about y equals greatest integer of 7.9? That will be 7. What about y equals greatest integer of negative 1.5? You might think that it's negative 1, but negative 1 is greater than negative 1.5. Remember, it has to be the greatest integer that is less than or equal to negative 1.5. So it has to be negative 2. So when you graph y equals greatest integer, you get a step function. You could also do it with your calculator and see if that makes sense. So we got limit as greatest integer of x. As x approaches 1, this means it's from the left. And this means limit of greatest integer of x as x approaches 1 from the right. These are examples of one-sided limit. So let's look at this. Here's a graph of greatest integer of x. Notice what happens as we approach 1 from the left. As we approach 1 from the left, what is the y value that you're approaching? The y value you're approaching is 0. What about this one? What happens as you approach greatest integer of x? As x approaches 1 from the right side. As you approach 1 from the right side, the y value you're approaching is 1. So what can we conclude? Let's say, do we have a limit as x goes to 1 of greatest integer of x? Well, it doesn't exist because when you approach 1 from the left, you approached 0. But when you approach 1 from the right, you approached 1. So therefore, the limit as x approaches 1 does not exist. In order for this to exist, whether you approach from the left or right, you have to approach the same number. So let's look at theorem 3, one-sided and two-sided limits. A function f of x has a limit as x approaches c. Okay, they're talking about this right here. If and only if the right hand and left hand limit at c exist and are equal. In symbols, this is what I mean. So whether you approach from the right, as you approach c, whether you approach from the right, and whether you approach from the left, you have to approach the same number. Then the limit as x approaches c of f of x will exist. Let's look at some examples. Let's look at graph of f of x. This is a piecewise function. Okay, you have 1, 2, 3, 4, 5 pieces, and when you graph piecewise function, you get this. So what is the limit of f of x as x approaches 0 from the right side? Notice, you can't even approach 0 from the left because the graph doesn't exist. You can only approach 0 from the right. So as you approach 0 from the right, what is the y value you're approaching? You're approaching 1. By the way, what is f of 0? F of 0 is 1. It's a good review. And let's see if limit of f of x as x approaches 1 exists. In order to find this, we first need to check whether limit of f of x as x approaches 1 from the right is equal to limit as x approaches 1 from the right. Left and right is equal to each other. So what is the limit of f of x as you approach 1 from the left? As you approach 1 from the left, notice you're approaching 0. You're getting very close to 0. What about 1 from the right? As you approach 1 from the right, you're approaching 1. So these two are not equal, therefore we do not have a limit as we approach f of x, as x approaches 1. By the way, what is f of 1? When x equals 1, the y value is 1 because you have a closed dot. It's not 0, it's 1. What about as you approach 2? Well, we have to check that as you approach 2 from the left, that is equal to same thing as when you approach 2 from the right. So what happens as you approach 2 from the left? You're getting very close to 1. Okay? What about 2 from the right? As you approach 2 from the right, you're getting very close to 1 as well. So we do have an answer for this. It's 1. By the way, what will be f of 2? What is the y value when x equals 2? When x equals 2, y value is not 1. It is 2 because you have a closed circle. What about as you approach 3? Well, we have to check whether these two are equivalent. When you approach 3 from the left, you're approaching the y value of 2, as you can see. What about 3 from the right? As you approach 3 from the right, you're approaching 2 as well. So they're equivalent, so we do have a limit, which is 2. And what is f of 3? What is the value of y when x equals 3? Well, the closed dot is right here, so it's 2. So in this case, f of 3 and limit of f of x as x approaches 3 are equivalent. And what is the limit of f of x as we approach 4 from the left? Now notice, we can only approach 4 from the left because there's no graph on the right side of 4. So what is it? As we approach 4 from the left, we're getting very close to 1. So that'll be the answer.